Numpy sum of operator results without allocating an unnecessary array. I have two number pi Boolean arrays, a and b. I need to find how many of their elements are equal. Currently, I do len a to the power of b, dot sum, but the XOR operation creates an entirely new number pi array, as I understand. How do I efficiently implement this desired behavior without creating the unnecessary temporary array? I've tried using numexpr, but I can't quite get it to work right. It doesn't support the notion that true is 1 and false is 0, so I have to use any.evaluate sum, where a equals b, 1, 0, which takes about twice as long. Edit. I forgot to mention that one of these arrays is actually a view into another array of a different size, and both arrays should be considered immutable. Both arrays are two-dimensional and tend to be somewhere around 25 by 40 in size. Yes, this is the bottleneck of my program and is worth optimizing.
To start with, you can skip the *b step. If you do not mind destroying array A or B, I am not sure you will get faster than this.
If the problem is allocation and deallocation, maintain a single output array and tell NumPy to put the results there every time. This will only work if the inputs are always the same dimensions, though. You may be able to make one big array and slice out a part that's the size you need for each call if the inputs have varying sizes, but I'm not sure how much that slows you down.
On my machine this is faster. If you don't want to use any extra storage, then I would suggest using number. I'm not too familiar with it, but this seems to work well. I ran into some trouble getting Python to take a Boolean NumPy array. If you don't have number, I would suggest using the answer by @user2357112. Edit, just got a Python version working, here's the .pyx file. I'd go with this.
Improving upon Iona's answer, it's also possible to get access to the underlying C array in a number pi array from within Python by supplying mode equals C tinned array. This is about 40% faster on my machine than Iona's Python version, and I've found that rearranging the loop contents doesn't seem to make much of a difference at this point, probably due to compiler optimizations. At this point, one could potentially link to a C function optimized with SSE, and such to perform this operation and pass a data and data as uint8_t*s.
If you want to support the channel, please consider liking and subscribing.